I'm thrilled you're here to talk about exploring geometric ideas with folks on Polypad. So let me switch my screen. Here we are. This is Mathigon.org. As you may or may not know, Mathigon is free for all students and teachers. So everything I'm going to show you today on the webinar is completely free for teachers, completely free for students. There are some features that I'm going to show you that teachers and students would need an account to do, but the vast majority of all the interactive pieces that I'm going to show you can even be done on Mathigon.org without an account. So on Mathigon, we have courses, Polypad, which is where we're going to spend most of our time today, and our activities. So I'm going to go to Polypad, and I'll go to the tiles over here. So in our panel on the left is where you find the tiles to put on the white space, which I'm going to call the canvas. And so there are a number of categories of tiles. There's geometry, where we are going to spend most of our time today. Numbers, fractions, algebra, probability and data, tools, and axes. So I'm going to start just in the polygon section. I can take a square, I can drag it onto the canvas. I'm going to zoom in a little bit to make it bigger. You can also put a shape on the canvas. I just clicked on the triangle, and there's the triangle. Now all these shapes have smart snapping, so you can kind of see that snaps right on top of it, and smart rotation. So it rotates nicely and snaps together. I'm going to click and drag here to select both of those tiles. And in Polypad, when you click on tiles, there are a number of options that will come up at the bottom specific to those tiles. One option that is there for the majority of tiles is the copy feature. So I'm going to copy this and rotate it. Now I'm going to be copying tiles a lot in the webinar this morning. Another way to copy tiles that I'm going to do a lot is just with the C button on the keyboard. So I click C and I made a copy of those, and I'll rotate it. I'll click C again, move them over here to complete my shape. And of course I want to put a hexagon in the middle. So I'll take this hexagon and drag it out. I can hold down the Shift button as I select tiles to group these together, and then hit the C button on my keyboard, and I'm off and running in my tessellation. I can take this and I can rotate the whole thing, move it over, click and drag to copy, and within a matter of seconds I have a really lovely beginning of a tessellation on my screen. I did something like this in both my 6th and 7th grade classes this past year. We looked at the ratio of shapes. We could explore the ratio of hexagons to squares and triangles. We looked at the angles that are needed to make a tessellation. I could spend an hour today just talking about all the wonderful math in tessellations. There's just an example with the square, hexagon, and triangle. Now, on the right-hand side of the Polypad are a number of tools. There's one is the settings menu. I just want to show you that one option is to change the color of the tiles. So as I click on this, you can see the colors of the tiles change if you use the pattern blocks in school. When I choose the colors that are on the screen now, it matches up with the pattern blocks that you might use with students. But I'm going to go back to these colors. Now all of these polygons, when I put them on the canvas, I can rotate them, I can move them, I can change the color, but I can't change the size. That's where we have the custom polygon. So in the custom polygon, any of the vertices of the polygon you can move to change the size of it. You can see here it starts off with 5 of them. If I want to add a vertex to the polygon, you can see as my cursor moves from the inside of the polygon to the edge, and I click plus, I add a vertex to the polygon. So I can add a number of vertices and move it all around. If there's a vertex that I don't want to have anymore, I can click on it and it goes away. So that's great. I'm going to show you a number of things over the course of the webinar where the custom polygon is really handy. Once I have a shape that I like, if I don't want to move it anymore, I'm pleased with this shape, one of the options at the bottom is to fix the vertices. So now it's a shape that I can spin around and I can move. I could change the color of it. There are pre-selected colors. There's also a color selector where you could enter in an RGB value, and the bottom one controls the transparency of the shape, which is pretty cool. I'm going to go back to the custom polygon and make a quadrilateral. a four-sided shape. Oh. And you may know that any quadrilateral, if you make a copy of it and rotate it around and put them together, you can make a tessellation. So I'll stick these two together. I could join this shape. There's an option down here to join. So I have two shapes I'm going to put together into one shape. Oh, let me try that again. Oh, there we go. And now I'll copy it and I have a tessellation. All right, so here we go. I'm off and running in my tessellation with that. I could copy the whole thing, stick them together here. My students have had great fun just making all sorts of wonderful tessellation with these shapes. I could change the color of some if I wanted to, and just have a great time making tessellations. So there's just a quick introduction to the polygons. At any point in this session, if you have any questions, feel free to drop them into the chat. I might address them as I'm going on, as I check the chat. I might miss it in the chat as I'm getting super excited about an idea that I'm talking about, and I will answer all of the questions in the chat at the end of the webinar if I miss it along the way. Okay, so that was a quick introduction to the polygons. Let me share some examples of how these could be used to help students think about the area of a shape. So I'm going to turn on a grid background. And so again, on the toolbar on the right, there's a number of grid backgrounds. There's a question mark. You can always be surprised. Right now, it was for Pride Month in June. That'll change over the course of the year. But I just put on this grid background. And I'm going to take my custom polygon and make a rectangle. Let me zoom in a little bit for us. And I'm going to make it, I'll get rid of this. I'll make it a 7x4 rectangle. 4, 5, 6, 7, and go down 4. So there's my 7x4 rectangle. I'm going to fix the vertices, and then I'm going to put a blue square on the canvas. And I might ask students how many blue rectangles or blue squares are needed to fill the rectangle. Maybe this is an introductory task about area. Maybe in middle school I'm doing a reminder for students about the idea of area. And I think I made it 7x4. So I'm going to add, I'm in a teacher account here. And in my teacher account, one option under tools and axes is a question builder. So I'm going to put this on the canvas. I'm now going to turn off the grid because I don't want my students to see the grid on this. And the answer is 28. So there's the answer of 28. I actually don't want students to move the rectangle or delete the rectangle by mistake. So I also want to show you under settings, I have advanced options checked. And when advanced options is checked, if you click on a tile, there's an advanced options feature down here, and I'm going to lock the tile. When I lock the tile, it's kind of affixed to the background. I can't select it, I can't move it, I can't do anything to that tile. So here's the square on the outside. I want to save this canvas and assign it to a student to explore with. So I'm going to go to File, and I'll call this Area 1, Intro or something, whatever I might call it in school, if I can spell intro here. And I'm going to hit Save. And now I've pre-made a class in Mathigon. I did a webinar a few weeks ago about all the teacher tools in Mathigon, how to make classes, how to assign it to students, how students can share their work with teachers. So I'm going to show you how to do this really quickly here, and then I'll show you where on Mathigon you can find that webinar on teacher tools if you want to go back and explore all of that. So I'm going to go to class. I currently only have one class in this Mathigon account. I have a separate account that I used in school that has all my classes in it. I'm going to assign it, and then I'm going to swipe to a different browser tab where I'm logged in as my daughter. So my daughter, her name is Emily. She's in my class. And I'm going to go to File in her account and just give it a reload because I just assigned something. And you can see in her library there's an assignments folder. And when I open that assignments folder, there it is. There is the assignment that I just created and assigned to her. And you can see it doesn't show the answer, right? So in the teacher account, it showed the answer of 28. Here now she could take these squares, she could copy them, she could fill these in, and then maybe she could copy all of the rows, fill in all of the rows if she wanted to. Maybe she could just put those two down here to see it's 4x7, and she might know that's 20, oh, not 27, I get the red X, it's 28. And there's the check, and the confetti comes down on the screen when you answer all the question boxes on a screen correct. Confetti comes down. This canvas, it only had one question box, so when she got it right, she got the confetti. She'll hit save, and then I go back to my teacher account, and when I do a reload here, you can see there's her assignment. It's orange. What that shows me as a teacher is she needed multiple attempts to get the question correct. There's only one question here, so that is telling me on that one question, she got it right, but she needed multiple attempts to get there. I'm going to show you some examples in a few minutes in the webinar that I used in class this past year with my students, and you'll see all the students here and their canvases. When I share my class with you, I'll have their names turned off to protect their privacy, but also as a teacher, this is a great tool. A number of students might have approached this task in different ways, and you might want to share with the class at the end of the activity all the different approaches that students did, and you could have names on and names off. So that's super fun. I'm going to go to a new canvas, so I'm in File. I'm going to hit this button for a new canvas. I'm going to turn on my grid background, and just a few examples as how you could use the tools to explore area of parallelograms and triangles. So I'm going to make a parallelogram with the custom polygon. Maybe I'll do something like this. So there's my parallelogram. It looks like it's snapped to the vertices. I'll fix those vertices, and then I'll make a triangle. And this, I would make a full canvas for students with lots of examples. We would do a lot of noticing and wondering and exploring, but for the purposes of this webinar, I'm going to go really quick just to plant some seeds of ideas, and then I'm going to show you where you can explore these ideas a little bit more on your own. Before I do this, I want to show you where you can find the videos on the teacher tools. So if you scroll all the way down to the bottom, actually, no, right at the top here, I'm going to go to the link for teachers. I'm going to open it in a new tab. So this only appears if you have a teacher account. It also appears if you aren't signed into a Mathigon account. You can click on for teachers. If you have a student account and you want to change it to a teacher account, let me show you what to do. I'm in my daughter's account now. I go to her student dashboard. Oops, no, I want to go to account settings. And I'd scroll down, and she could change it to a teacher account. I don't want her to, but if you made a student account and you want to change it to a teacher account, that's how you do it. So in there, if you click on For Teachers, open it in a new tab. Let me just give you a quick tour of the teacher page. Here's an overview. If you click on Events and Webinars, here are all our past webinar recordings. So this webinar on teacher tools is a whole webinar on how to make classes, how to assign students, how to view their work. So I did a really quick example of that. You could go watch that webinar in more detail if you wanted to. And then under tutorials are some shorter videos on how to make classes, how to share and assign Polypads, how to use the question builder that I just showed you. So all sorts of great webinars and tutorials in the For Teachers tab. Okay, do students move? There's a question in the chat. Do students need to move the blocks, or can they put the answer in without movement? Yes, they can put the answer in anytime they want. So if they put in a single block in that rectangle example and then want to make a prediction and then get feedback if that answer is correct or not, they could enter the answer into the question builder anytime they want. All right, what I think is really great about the available tools here is the cut option. So as a teacher, when I've explored area of parallelograms and triangles, we've given kids graph paper and they've cut them out and they've moved them over with tape and glue sticks, and it was kind of a mess. And I feel like the craft side of things got in the way of the mathematics. Well, here, when you click on a polygon and one of the options at the bottom is to cut, I can just click and drag and cut any polygon I want and move that triangle over here to make the parallelogram into a rectangle. That easy. In a triangle here, I'm going to copy the triangle and put it down here. I could take this and copy it and change the color and spin it around to double it to make a parallelogram, and then I could take this and use the cut tool and cut it and move it over here. And of course, when I did this with students, I didn't show them this. I just gave them a shape and said, go find the area. And they explored with the cut tool and the movement tool to try to double the shape or cut the shape in half. all sorts of ways that they explored, and then they shared their ideas with the class. I could take the triangle and I could cut it up here and take this shape and copy it and rotate it like this, and maybe change this color to orange and do the same over here. And so I've taken the same triangle and arranged it into a rectangle a couple different ways, but I could take this rectangle and put it on top to show it's the same rectangle, and in each time we took the triangle and doubled it. And so it could lead to a good conversation around the area of the triangle being half of a rectangle. Let me share with you an example that I did in class this past year, which kind of gets at the question about do they need to move the blocks to put the answer in. So I'm now going to swipe to my account as a teacher. So my school is a Google Classroom school, so all my Google classes were linked to my Mathigon account. This is a canvas that I assigned to my class in 6th grade as we were exploring the area of right triangles. These are all the student canvases. So you can see I'm in class. Here are all my classes. I don't want to show you the student names, but I could. If I click that, all the student names would appear. The first one is always the template that you assign to the class. So this is the template that I assigned. Because it's the one I assigned, I can see all of the answers. This was a really quick, like a warm-up in class. I don't even have instructions on it. I just told the kids, go find the area, and they went off and running. Here's a student who found the area in a number of different ways. I think she took the triangle and made 4 of the triangles to make it into a bigger rectangle, and then found a 4th of that, which is great, right? Not what I would have thought, but a fun way to explore that. You can see as she got to the ones at the bottom, she was doing more of take the triangle and make a copy of it. Here's a student who had fun with the backgrounds. Let me give it a reload here. There we go. That one's not loading for some reason. Let me go to this one. This is a student who took the triangles and doubled them and found the area. But then, so, as a teacher, this is great feedback for me that the student explored this task in a variety of ways. This is one that I shared with the class. And, this student explained how she used 3 copies of the triangle to make a rectangle. And then, I could see as a teacher that this is an example of a student who had already abstracted the idea. The student could visualize that it was half of a rectangle and didn't need to take the tool and copy and flip it to find the area of the triangle. So some really nice examples there of how, as a teacher, you can get feedback in the moment as to whether students were still in a really like a concrete phase or a more abstract phase. In my 7th grade class this year, we explored the Pythagorean Theorem, and I just want to show you a quick example of how we explored the Pythagorean Theorem. This I made for the webinar. So in class, when I was doing it in class, I had students just build a triangle on the canvas. They used the ruler and the protractor tool to build the squares on the sides of the triangle. In the interest of time in this webinar, I'm not going to do that. This is a pre-made canvas made for TV here. But imagine kids had gone through the experience of draw any triangle that you want. And students might have drawn a right triangle, some might have drawn an obtuse triangle or an acute triangle. And then as a class, whatever triangle they built, we talked together about how to use the ruler and the protractor to build a right angle and draw squares. And then we did a lot of noticing and wondering, and we got to the point of we wonder how the area of these squares compare to the big one. And with the custom polygon tool, right, I can just drag the vertices into the square, and get rid of that and fix those vertices. So now it's a square that I can move, but I can't change it. I'll go over here and do another one. And again, this is an activity that before Polypad I did it on paper. I've seen people do it with Cheez-Its, which is great. But the paper version that I did on graph paper was kind of a mess, and kids got lost again in the cutting and the art of it. And here you can just take this and put the square here. It snaps together really nicely. I'm going to go to my cut tool and cut this up. And students really enjoyed this activity. I'd found in the past when it was graph paper and scissors and tapes, there was a lot of groaning. There was a lot of, oh, this is kind of a mess. Why do we have to do this? Which I was surprised on. I thought it'd be kind of like a fun activity. I don't know if, the students thought the the paper was kind of elementary and having to cut things out. But here, like, this was enjoyable for kids. I'm enjoying it too. I've done this a lot of times, but I'm still having fun. And I can take this piece and put it in here. I'm going to stop here. I think you get the idea that it's not going to be perfect, but it's going to come pretty darn close. And that's a great conversation to have with students who made a right triangle. I'd cut that, I'd move it around, right? And then when students made an obtuse triangle, we would talk about how these two squares don't even come close to filling up the square on the hypotenuse. At this point, I hadn't even called this hypotenuse yet, right? We were just exploring how the areas built on sides of triangles compare to each other. And then here's an example of an acute triangle. But in class, it came through very organically because all students had made all kinds of different triangles. And as I showed you here, I could share all of the canvases that students made in class on the projector, which was great. I enjoyed that very much. All right, so that's how to explore Pythagorean theorem. Yes, this is being recorded. Is it easy for students to add text? It's super easy. I just clicked on the text button and I can add text or add text. A few things to pause here. I want to show you at the bottom is a link to a tutorial page on all the general tools on Polypad. So how to add text, how to save a Polypad, how to share a Polypad. So that's like a general tutorial on Polypad. You can go through and explore that. So that's tutorial at the bottom. And then as you see here, when I expand a tile category, there's a question mark that appears that also brings you to a tutorial page on those tools. So here's a tutorial page on the tiles in the geometry category. All right. I think that's most of the questions in the text. Let me keep going with another example that I want to share with you about how students could explore finding the area of a circle. In general, what I think is really powerful here, there are so many amazing videos and animations out there that show a parallelogram changing to a rectangle, that show the area of the squares on the legs filling up the hypotenuse, that show what I'm about to show about the area of a circle. Here, it's so inviting and easy for kids to do it themselves. And I certainly think there's a difference between watching an animation and talking about it. And some of these animations are amazing, right? They're really engaging for kids. But to take it one step further and have students do it themselves, those connections in their brain are getting much, much stronger when you do something on your own than when you watch an animation. So that's what a piece of these tools that I'm really excited about. So let me go to a new canvas. Actually, for the magic of the webinar, I've started this off just to save a little time. Here I've built 10/12ths of a circle with the fraction tiles. So I'm going to go to the fractions. I'll add on one more 12th and rotate it down. And then I'll add another 12th and I'll rotate it down. And I've done this in school a lot where I've told kids a story about I bought a pizza and it came in a circle, but I wanted to reheat it and the pizza couldn't fit in the oven, so I arranged it into a rectangle and I was drawing the pictures on the board. And it was fun. I think they enjoyed the story. But now I can have them do that same thing on their own, much more engaging for the students. So I would take the custom polygon tool. I'm going to make a piece using the custom polygon tool. So I might say, all right, that's pretty good, but I'm going to add a point here just to kind of pull it out a little bit. So there we go. That one needs to come out a little bit more. And that looks like a pretty good attempt at a piece of pizza. So now I'm going to fix the vertices. I'm going to take this shape and copy it and rotate it over here. And then there we go, that'll look good. Take another one and rotate it down and make this one maybe a different color. I got to stick them together here. There we go. Well, let me see if I can do a little better job of sticking them together. That should work better. Now I'll stick them together. Oh, no, let me. I think that'll come together nicer. And then I could copy these, and I need 12 of them. So there's 6, and then there's 12 of them. All right, so there are 12 of those things, of those wedges, all coming together to make the pizza. I have little gaps in there. In the interest of time, I'm not going to go back and make that custom polygon better to fix those gaps, but I could click all of these and hit join, and now I've made one single copy of those. So I've joined them all together, and now I can take this and I'm going to copy it one more time and put it down here. And I'm going to go to my cut tool, and I'm going to cut it right here like I was doing with the parallelogram. Move this over here, and there I've made it into a rectangle-ish, right? And so then I'm going to go to the construction tools. I'm going to show you the construction tools in 1 second, but I'm going to go to the construction tools and draw a black line to kind of get an outline of the rectangle. And what's nice on the construction tools, when I click on it, a number of things come up, which I'll expand on in a minute. But if I click on these dots here, it shows me the length of that line. So I could click length of the line is 6.5 units. And then I can click on this line and see that its length is 2 units. So I'll go to a text box here, 2 units. And what's that? 13. Is my arithmetic correct on a summer morning? 13 units is an approximate area of this rectangle. It's not quite a full rectangle, and it's an approximation. So it's about 13 units. I left off my S here. And then I can go to my construction tool and make a circle around this. I'm just clicking and dragging to make a circle. And if I click on the circle, I can find the area of the circle, 12.6 units, right? So a good approximation, 12.6 units. Square units. Oh, I left off my square down there here as well, right? 13 square units. My students would have called me out on that, I hope. All right, but a good way to show an approximation of the area of the circle. And again, awesome animations out there doing it. We have a great one on Mathigon showing this happen without these little gaps here. But having students do it, I think, is a really powerful idea. And then certainly, you know, I'd expand upon this, right? We'd make all these a certain color and talk about that's half of the circumference and prove the formula, right? But to show that visual of the proof of the formula, I think is really powerful for kids to do it on their own. All right, let me show you something on these construction tools. So I'm going to go to a new canvas, and I'm going to draw a line here, and I'm going to make a triangle. So I'm using the construction tools to draw 3 lines to make a triangle. I want to show you that when I click and drag, oh, I'm going to reload this just to give me a fresh start. All right, let me try again on the triangle here. So here we go. I'm going to draw a triangle. Go back to the tile panel. When I click and drag on the triangle, I could find the centroid of the triangle. I could draw the circumcircle or the incircle. I'm not going to do that right now. You can go play with that on your own. But I am going to just show you that when you click on these 3 dots, it shows you the area, perimeter, and the interior angles of the triangle. But what I want to do for now is first, so now I've clicked on a side of the triangle, and one option is that I can add the midpoint of that side. So I'll do that for the 3 sides. I'll find the midpoints. I will change my color to purple and go to the line tool, and I'll, oh, wrong swipe. I will connect the opposite point with the midpoint. And they cross there, and you may know that all 3 of these lines cross at the same point. So I'm going to put a little point right there. There's a vocab name for that, which I forget. You can put it in the chat if you know the name for that vocab point. And then as students move the triangle around, they see that that point stays in the same place. Of course, I'm showing this really quickly. In school, I would do a lot of noticing and wondering, right? What do you think might happen if we find the midpoints and draw the lines? Try it on your own, see what happens, right? I'm just doing this to show how the tools work and hopefully share some ideas with you about how you could incorporate this into your practice in a more exploratory, playful kind of notice and wonder way. So just want to put that out there too. All right, and now I want to, maybe I'll go to red here, and I'm going to click on a line, and let's draw in the perpendicular bisector of each side. So I've clicked on the side, and I'm clicking perpendicular bisector. You can see they met outside the triangle here, but I draw that in, and they all meet at the same point as well. And when I move the triangle around, sometimes that point is inside the triangle, sometimes it's outside the triangle. You could have students say, is there any way to get that one inside or outside the triangle? All sorts of fun discussions. Really could do a deep dive in this. I'm going super fast and just showing, not really exploring with you, but that's what we're doing in the webinar. And the last one to show, let me make this one, I'll do blue here, is I'm going to click on a side and find a line that is perpendicular to that side. you can see I can draw the line anywhere I want. I want to go through the opposite point. So I'll do that one here. I'll click on this one and do a perpendicular line connected to that point. And I think the last one I have to do is this one with a perpendicular line. I'm making a mess, but those meet at the same point as well, which is really exciting, right? So there's a point. And the really awesome fact, so all of these blue, purple, red points have names. I forget what they are. I could Google them and find them, and I certainly would if I was teaching this with students. But if I draw all of these, let's do green here, all of these points, you may or may not know, lie on the same straight line. So you can see they're connected, and they fall on the same line. As I move any point around, that green line always stays the same line. Or those 3 points are always on the same line. My picture's kind of messy here, so what you can also do, I'm going to hold Shift. I'm going to select all the blue, red, and purple lines. I'm holding down Shift as I do it. And one of the options here is to make them invisible. So watch this. Oh, right? I've made them invisible, and all we have is the green line. So you can move it around, and you could ask students to maybe make a prediction with the pen tool. They could take the pen tool and draw the lines on the canvas to see if they can think about where those lines would be. And then once they've made their prediction, then you can go over here and do show and unlock all, which is really fun. And then you could try to make all 3 of the points line up. Isn't this really satisfying? Oh my goodness. How cool is that? Oh, thank you for the words, Eric. Circumcenter, in-center, centroid. Thank you. All right, and so I can get all of those awesome vocab words to meet up at the same point, which is really cool. So that's some of the construction tools. Just a few things that you could do. Obviously, when you click on a shape, I think I showed you all of these except the parallel line. And again, when I select a triangle, I can find the centroid of a triangle. If I just draw a triangle here, I just want to show you when you select the triangle that you can get the circumcircle and the incircle of, oh, I did a parallel line, but I could also get a circle on the inside, right? So great stuff can be had with the construction tools. Okay, awesome. I don't think I've missed any questions. I might have put them in the chat though, and you can, I will answer all the questions at the end. What I want to show you is a sneak peek of something coming soon on Mathigon, coming within the next couple weeks. This was put out on Twitter a while ago. If you're watching this live, it's coming out in a couple weeks. If you're coming back to this recording, it might be live now. So I'm in a preview mode of Polypad. So this is not live yet. I've had a good time playing around with it. So I'm going to take a square and put 6 of them on the canvas. I'm using the C button just to copy paste here. So there's 3, 4, 5, 6. And you can see I've made what looks like a net. And when I click and drag and select all of these, a new button, again, it's not live yet. This is July 27th, coming soon. There's still some bugs that have to be worked out. The flip button was there, cut and join was there, but a new button coming soon is fold net. So when I click fold net, it folds together. How cool is that? And then I can click on this cube and rotate it around the canvas. This black handle is how you move it around the canvas. And again, if you just click and drag on it, it'll rotate around. You can unfold it and then fold it back together. And there's also a slider here, so you could unfold it and stop at any position that you want and take this and spin it around. How amazing is that? I'm so excited to explore this with my students next year. And then you could take something like this and ask students, what are all the ways maybe to take these 6 and make a net? And they could just go explore, right? Does this make a net of a cube? Sure does, right? We know that one makes a net. There it is. I know, I'm doing it again. Yeah, I know. I could spend the rest of the webinar doing this. It's so cool. But what also I think is awesome is students could, maybe try something like this. Some students might think, that's going to make a net, right? And so I could take this, I can click and drag, and some students are really good at visualizing what makes a net, and some students might want to click fold net and see what happens. It looks like it made a net, but as you can see, there's no top or bottom or side, depending on how you spin it. And what's really nice is to be able to unfold it and kind of go back and forth to see what happens. Oh yeah, so these two ended up on top of each other. right? Yeah, I think I'm doing this in the chat right now. It doesn't make a cube, right? Those don't go on top of each other. It can fold though, right? So that it's possible to fold that thing. You could have 3 that can fold and make something. That just makes that thing, right? But then there are some that actually can't fold, right? So this guy, this shape, oops. There are, this is still not quite ready to be published yet, but it's coming. That one, he says, this is not a valid polyhedron net, right? That can't actually fold. So there's some that can fold even if it's not a cube, and some that will do that. And I'm seeing in the chat, can other shapes do it? Great question. So let's take a pentagon, and I'm going to turn on the grid background just so I can line things up. And I'm going to go to the custom polygon tool here. I'll make it a different color just so it can stand out a little bit. And I'm going to make a pentagonal prism, right? And so I just have the grid background on so I can make sure the prism matches up exactly. So I'll do this, I'll fix the vertices, and now I need 5 of these. So because of the smart snapping and rotation, I can copy 2 of them and put them into place. And because I fixed the vertices, I know all of these are the same size and shape. They are congruent rectangles here that I'm putting together. But like, what a great activity just for kids to go do, right? Again, I'm showing you this. This is not how I would do it with students, right? I might maybe show them a picture of a 3D shape and say, go build the net. Can you put this together? So here, this is one I've just built from scratch, and fold the net. Whoa, I know. So cool, right? And like, you can unfold it along the way and pause anywhere you want. So this is, I think, a really like game changer of a tool for kids just to explore with building nets on their own. I think it's just so easy to do. It's so inviting. I could turn off the grid here. Let me show you one last one. I have other things to show you in this webinar, but I could spend all day doing this. I could do 6 of these put together, right? So let's do 3, 4, 5, 6. I got to get this cube out of the way, right? Boop. And is this going to make a net? Shouldn't, right? But what's cool about it is you can see the gaps here, right? Oh yeah, we have those triangles that need to be filled in, which is pretty cool, right? So I could unfold this, boom, right? And try to stick a triangle in there. Now I think these are some of the, I don't think it's going to select all of them right now. I was playing around with this before. So what I might need to do is make a new one. These are some of the tweaks we still have going before it comes out to the public. I could think about where that triangle needs to be. Whoop. Maybe I'll put the triangle over here and see what happens. And again, like, what a great exploration for students to think about as they're doing it. Let's fold this and see what happens. Oh yeah, so there's the triangle in place. You can see as I move it around, there's an example of why it's not quite public yet, but it'll be pretty amazing when it comes out. And then there will be some pre-made 3D solids. So there's an example of the prism that I made. Here's a pyramid. You can certainly make a pyramid and unfold it and have all sorts of fun with that on a bright sunny day. We have a dodecahedron that, again, you could ask students to make or have them put it back together. So really exciting. Coming soon, I think we'll to a Polypad near you. So I'm going to move on from the 3D section. Again, we could play with that all day. A cylindrical net, not yet, because we don't have a circle that is part of the polygon tools. You can make a circle as I showed you with the constructions, but that might be one that would be added to the pre-made solid. So stay tuned on that. All right, let me go to a new canvas here. I'm just having too much fun. Again, I'm just trying to throw a lot of ideas at you, plant some seeds about how you could use this with students. We focused a lot of time in the polygon section. There are pentominoes and tetrominoes. I'm going to show you a place to find activities for those in a few minutes. There's the classic tangram and the magic egg. I did a fun activity with students over this past year. It was kind of like a last day or a last week of school. Everyone was sort of on their the last gasp of the school year, and I had students just make anything they wanted with the tangrams. I'm not doing a good job of keeping track of what shapes I have. I think that's all 7 of them. And now we can click join, and it makes one shape, they could save it, share this with students in a Google Doc or something, and have students try to make their shape with their tangrams. That was super fun. But I want to show you the Penrose tiles and Pentagon tilings. So let me go to File, New Canvas, and I'm going to go to the Penrose tiles. So the Penrose tiles, as you make a piece of mathematical art with the Penrose tiles, the circles have to connect. So any shape that you make, you have to put them together in a way that the paths connect. So I'll maybe do something like that, and then I'll take the blue one and think about how I could get the blue circle to connect. Maybe something like that. Oh, let's put this down here maybe. There we go. And I could go off and running and try to make a shape where all the lines connect. What is great about this, it creates a non-periodic tessellation. So it's not the same pattern over and over again, but it makes a tessellation. This was an amazing discovery of recreational mathematics, that these Penrose tiles create a non-periodic tessellation. I just want to show you an example of one. There is a folder in every Polypad account called Examples and Templates. And if you click down here, there's a Penrose tiling. So I'll discard this, and here's an example of a much nicer than the one I would make on the webinar, a Penrose tiling. How beautiful is that? So it's a non-periodic tessellation. Really cool. The other one I want to show you is the Pentagon tilings. So I'm going to go back to geometry. I'm going to click on the instructions. And in the instructions, again, this is all the instructions on how to use the Polypad tools. And here's an example of the Penrose tiling that I just showed you. Here's a Pentagon tiling. So let me go to the Pentagon tilings. You may know that a regular pentagon does not tessellate, but all of these pentagons do create a tessellation. So here's one that was made with the same pentagon. It was all made with this pentagon, just the colors were changed to make it look a little nicer. So the most recent pentagon that tessellates, I think, was found in 2015, and it was recently proved that this is the complete list of all pentagons that tessellate. So a good example of new discoveries in recreational mathematics happening all the time. We have a whole other category of patterns in art with tantric tiles, fractals, and column tiles. You'll notice that on some of the tile types there's a little a pop-up icon, which if you click, it'll take you to a page on those tiles. So here's a great page on column tiles. I encourage you to explore. And then, yeah, we can leave this. And then in this introductory page, it's an example of the nature tiles. You can make some awesome patterns with tantric tiles, fractals, and column tiles. There was a teacher who put out on Twitter a couple weeks ago that she found her students had saved Polypad as a bookmark, that it was just something they enjoyed to do when they were feeling stressed or anxious. They just like to go play with the art on Polypad. And what an awesome thing to hear, that engaging with these tools was an enjoyable thing for students, that when they were feeling stressed or anxious, coming here was calming and enjoyable for them. Was great to hear. So all sorts of cool tile types here. I want to share with you a few last examples. As I said, I'm a 6th and 7th grade math teacher, and there were a few times over the course of this school year where having a Polypad just up and ready to go in case was really powerful for students to use to be able to share their thinking with their classmates. So here's an example of a question that was on their homework. I have it pre-made for the webinar, but the homework question was just this. This is just a screenshot of the homework question. It is so easy to import an image into a Polypad. I had this on my desktop. I just dragged it onto Polypad. There's also an upload image button down here at the bottom. If you click that, you can upload an image, but I just do a screenshot, save to my desktop, drag it on. So in class, there was a student that was talking about how she pictured the white parallelograms just kind of moving up and the gray shapes moving down. And she was describing it, and I was trying to draw it on the board, and sounds like I'm making this up, but I'm really not. There was another student that was like, Mr. Poras, just do it on a Polypad. You know, they knew of my love for Polypad. So I was like, oh, great idea. So I went and I did a bunch of the custom polygon tools and fixed the vertices, and I made this on top. And so then I went back to the student. I was like, okay, explain more to the class what you're doing. And so she said, move the red ones out of the way, push the green ones down. They kind of snap together. Put these over here. And then she's like, and I bet those things kind of fill up the space down below. And I was like, okay, that's like a good assumption. We can actually check it. Let's cut it and move it around and see. I might have missed my cut a little bit, but I could take this and we could move it down, and oh yeah, fills it up pretty nicely, right? And so I didn't do a great job here, but that student in the moment, the rest of her classmates had an aha moment of like, oh, I see what you're doing. This rectangle is 9 by 4 because there's the 4, and this one was 9 by 9, I guess, and then we found the error. So it was so easy in the moment to have this tool up and have the student use the tool to share their thinking with the class. Another example, which I've shared on some prior webinars, so if you've seen this, I apologize, but I think it's so powerful, it's worth sharing again. What I haven't showed you today, which I'm going to spend the last 5 or 7 minutes talking about, and then I'll do any questions in the chat, is our task page. So all the way at the bottom under lesson plans is our task page. You also can get there anytime you go to the For Teachers link. There is our events and webinars. There are our tutorials and our task page. And one of the tasks we have are visual patterns. So I'm sure many of you have used the visual patterns at visualpatterns.org in your class. We have a link down to visualpatterns.org at the bottom. Right, so awesome. But all sorts of wonderful visual patterns to explore with students. I just want to share with you this one. This is visual pattern number 19. This is number 19 from visualpatterns.org, right? And so here students can put in the box what their answer is. What's this one? 10, and so on. But I have a pre-made one for the purposes of this webinar. I feel like a chef saying, here's the cooked dish I was making. Where am I going? Geometry webinar. So I had this kind of prepared because I knew students would be sharing a number of ways that they engage with the pattern. So certainly there were students that described how they saw it as a big rectangle with one tile on top and one at the bottom. Great, I could use colors really nicely to show that. We proved that. This was the 6th one, I think, and we went to the nth one, and we went through the algebra of that. And then there were students that said, oh, I saw it as a square, and then a 2 by something rectangle, right? And we made that a different color, and that was awesome. And we went through and proved that for the 6th one, algebraically, simplified it. Awesome moment. And then there were kids, of course, that said they made it into a rectangle. So I'm going to copy all of these, move them up, make it a different color. We'll go blue this time. Copy that. Oops, I missed. I think you get where I'm going here. I'd copy this, move it down, copy one more. So they filled it in and made it a square, went through the algebra again, it was great. And then there was a student at the end that was going through an explanation that I honestly couldn't follow in the moment. And she was, I think, at the board doing it, and she talked about how there was the long one, and she was like, kind of move the long one, like get it out of the way. And she went to the board to draw something, and then I did it on a Polypad. And so she said, take that long one and just kind of move it out of the way. And I was like, great, I can do that. And then she said that I should take the one that's left and move it over. Did that. And then she said, take this one and rotate it, and put it on the bottom. And then she said, and I saw it was a square with one left over, right? And it was such an awesome moment for her to be able to clearly articulate what she was seeing in this picture with the class. When she was first trying to describe it and do it on the board, I could tell I had trouble following it. Her classmates had trouble following it. But then when she did it, or had me do it on Polypad, because it was not at the time yet where devices were being shared, so I had my laptop plugged in. I didn't want, she shouldn't be touching my laptop at that moment. I was doing it for her, and she had her moment. Kids were in awe and really impressed and excited with how she shared her visualization of that pattern. And the tool allowed her to have that moment, which was really exciting for me as a teacher. So that was really exciting. I'm going to spend the next 5 minutes or so sharing a few things more from the task page, and then I will open it up to any questions in the chat. So we have a few games that I think are great. One is the puzzle of the day. I'll just open this in a new tab so I can come back to the task page. This actual puzzle is made by a puzzle maker in Norway, which I'll show you the link. I'm just going to go right to the game board here. So I'm going to go to the game board. There's a link to the Dragon Fjord Puzzle Company. It's a really well-crafted, small puzzle made out of wood. I encourage you to go buy one. My family and I enjoy the puzzle. It's a different puzzle every day. The goal is to use these pieces to cover everything except today's day and month. So I think today is July 27th. So I might take this one and I would rotate it over and cover up the 27th. I might take this one and rotate it over, and there I got July covered. I'm going to stop here. I could spend all day doing this. And every day has a solution. And so I had students go to this Polypad. They saved it into their account. Anytime they had a few extra minutes in class or on their own, they could just go to the puzzle of the day and go do the puzzle of the day. So that is super fun. You may have heard of the Genius Star and the Genius Square. I'll show you the Genius Star. These are made from the Happy Puzzle Company. We have a link to their site where you can actually buy the puzzle. You can use Mathigon as a discount code for 10% off. We're sharing these puzzles with their permission. So really appreciate their openness to partnering to get a virtual version of Genius Star and Genius Square. It's an awesome board game. Again, I have the actual game at home. I encourage you to get one and explore with the physical puzzle as well. The way this works, I've clicked and dragged all the spinners. I'm going to spin all the spinners. And you can see this first one's on 48. So I'm going to take one of these gray triangles and put it on 48. This next one, I might need to spin again. It's right on the middle. If you double click on the arrow, it'll spin again. So there's 39. I'll put this one on 39. I'm going to do this really quick. Here's 20. 27 is this way, 8, and obviously I could rotate these triangles if I needed to. 12, let's see if I don't, and the last one is 36. So close. I need to rotate this one. And then the challenge is to use all these pieces to, to fill in the shape. So I might put the triangle here, right? This green one would go here. And again, every puzzle has a solution. This was made by a Algerian puzzle maker and partnered with the Happy Puzzle Company to make a version of this. In class, what I do with class, I don't have 25 versions of the puzzle in class, so I have this projected on the screen. I spin all the spinners, I read off the numbers, so everyone is working on the same puzzle. So it's a really nice way to do this in a fun, lighthearted way in class, see who can solve the puzzle first, but then we keep going because so many of the puzzles have lots of ways to solve them. So there's the fun of who got it first, but then keep going, and then students can save it, and then I can share up on the projector all their solutions, which is great. So let me go back to the task page. I think I just got to go back here. Yep, I don't want to save my changes. A number of things to share on the task page. There is a great exploration on Pick's theorem. Let's see if I can spell it right. So Pick's theorem, if you're not aware of Pick's theorem, a great exploration for students to think about the area of a shape based on the number of dots on the perimeter of a shape and the number of dots on the interior of the shape. And then there's some polypads where you can go actually explore the theorem. So these are embedded polypads into this activity. There are links to the polypads as well. So that's a fun one to explore. Here is one on spidrons. There's a video on it, and then some math around the construction of the shape. So there's a ruler and a protractor and some instructions on how to draw those shapes. Let me show you a few more. There is one on rhombic dissections of dodecagons. Right. So here's a introductory canvas that you could share with students about how to make a dodecagon with rhombuses. And then here's just an example of the 15 ways to make a dodecagon with these shapes. So certainly I wouldn't share this with students. I would just say, here are the shapes you can use. Go make as many dodecagons as you can. But from the teacher standpoint, here's a solution of all the ways to do it, and a link at the bottom to find more information. One last one to share that I think is fun for students of all ages to explore. You may have played around with Curry's paradox before, and so the task is to use these 4 shapes to fill in the triangle. I can rotate them around and fill them in. Right, and then the next one has a hint if students need a hint. That's what I just did. And then now take the pieces and put them in the triangle as shown below. And surprisingly, here's the paradox. We got an extra square. Where did that extra square come from? We can see it in an animation here. I'm not going to scroll down because it's got the solution and explains the math behind it. But this could be a fun activity for students to explore and get them stumped on what's that missing square all about. Wait, what? I took this and I had it like that. And then we have the missing square. Really cool. Awesome. I could keep going. It is 3 minutes before the hour. So just a few things in conclusion that I just want to share with you. Again, on the For Teachers tab, I went really fast. I showed you a number of things. This is being recorded. Of course, we'll have an edited version up live within a day or two. But this recording will be live as soon as the webinar is over. You can go to events and webinars and see our past webinars. Tutorials is where you can watch some videos on kind of the teacher tools, and then there's our task page that has a number of tasks, not just focused on geometry, but all sorts of areas of mathematics. You could do a search here. There's a couple on the mean, if that's a topic that you might be exploring with students. It would be fun to check out. On Polypad, again at the bottom is our first tutorial page that has a tutorial on just all the general tools on Polypad. And then if you go all the way to the bottom, there's a link to just our tutorial page in Polypad that has links to how to use the geometry tools, how to use the fraction tools, how to use the probability tools. And again, those are the same links that can be found in the question mark that appears here. Finally, every now and then you might want to check out our What's New page. You can see we've had a busy summer of June and July, adding a number of tile types. We have some fun ones coming, as you saw with our 3D shape. So I think it was here. I'm still in the preview mode, so you can see. Oh, maybe I'm not in the preview mode anymore, but you saw in this webinar some of the fun tools that we have coming soon. And finally, last thing, and then I'll go to questions. If you go to mathigon.org/events, we have a number of webinars over the rest of the summer. And we're also really excited to announce a guest speaker series over the course of next school year who are going to come and share some great just thoughts about mathematics in general, math education. So encourage you to go see the list of amazing math educators that are joining us for our Mathigon guest speaker series over the upcoming school year. So go check that out. Again, that's mathigon.org/events. I'll put that in the chat as well. I've had a great time talking math at you today. I hope you found this a good use of your time. If you're still here, I'll take that as a yes, because you could have left anytime that you wanted to. I will stay on and answer any questions that you have in the chat. I'm going to officially say thank you very much for coming. Again, all of these tools completely free for teachers and students, so go explore, play, engage your students, have fun. So thank you very much. Have a great rest of your day.